Hello, everyone. Welcome to Financial Thinking. I'm Robson Andrade, and today, we're diving deep into the fascinating world of blockchain technology. In this video, we'll explore what blockchain is, how it works, its applications, benefits, challenges, and future trends. Let's get started. What is blockchain technology? Blockchain technology can be described as a digital ledger that's decentralized and distributed across a network of computers known as nodes. Each block in the blockchain contains a list of transactions. Once a block is completed, it's added to the chain in chronological order, creating a continuous and unalterable history of transactions. This innovative structure is fundamentally different from traditional databases, which are typically centralized and managed by a single entity. The basic components of blockchain technology include blocks, chains, nodes, and consensus mechanisms. Blocks are the individual units that store data, and they are linked together in a chain. Nodes are the computers that participate in the blockchain network, validating and relaying transactions. Consensus mechanisms are the protocols that nodes use to agree on the validity of transactions. One key aspect of blockchain technology is its security. The use of cryptographic techniques ensures that data within the blockchain is tamper-proof and secure. Each block contains a unique code called a hash, which is generated from the data within the block. Any change to the block's data will alter the hash, making it immediately apparent if any tampering has occurred. Additionally, each block contains the hash of the previous block, further securing the chain. How does blockchain work? The process of blockchain operation involves several steps. When a transaction is initiated, it is grouped with other transactions to form a block. This block is then sent to the network of nodes for validation. Nodes work together to verify the legitimacy of the transactions within the block. In many blockchain networks, this validation process involves solving complex mathematical problems, a method known as mining. Miners, who are participants in the network, compete to solve these problems. The first miner to solve the problem gets to add the block to the blockchain and is rewarded with cryptocurrency. This method, known as proof of work (POW), ensures that all transactions are verified and secure. Once a block is validated and added to the blockchain, it becomes a permanent part of the ledger. This means that the transaction history is immutable and transparent. Any attempt to alter a block will require changing all subsequent blocks, which is practically impossible in a large and decentralized network. Applications of blockchain technology. Blockchain technology is not confined to cryptocurrencies alone. Its decentralized and secure nature has opened up a wide range of applications across various industries. Finance. Blockchain is revolutionizing financial services by enabling faster, cheaper, and more secure transactions. Cross-border payments, which traditionally take several days and incur high fees, can be completed in minutes using blockchain. Smart contracts, which are self-executing contracts with the terms directly written into code, are also gaining popularity. They ensure that agreements are automatically enforced, reducing the need for intermediaries. Healthcare. In healthcare, blockchain ensures the privacy and security of patient records. It allows for the secure sharing of medical data between different entities, such as hospitals and insurance companies, while maintaining patient confidentiality. Blockchain can also be used to track the supply chain of pharmaceuticals, ensuring the authenticity of drugs. Supply chain. Blockchain enhances supply chain transparency by tracking products from their origin to delivery. This can help prevent fraud and counterfeiting, as each step of the product's journey is recorded on the blockchain. Companies like Walmart have successfully used blockchain to track the origin of their products, ensuring quality and safety for consumers. Voting systems. Blockchain technology can provide secure and transparent voting systems. It can ensure that votes are counted accurately and that the voting process is tamper-proof. This could potentially eliminate the risk of election fraud and increase public trust in the electoral process. Advantages of blockchain technology. Blockchain technology offers several significant advantages: transparency and immutability. Every transaction recorded on the blockchain is visible to all participants in the network, making it highly transparent. Once a transaction is added to the blockchain, it cannot be altered or deleted, ensuring the immutability of the data. Decentralization and security. Blockchain operates on a decentralized network, reducing the risk of a single point of failure. This decentralization enhances security, as it's much harder for hackers to compromise the entire network. The use of cryptographic techniques further ensures the security of the data. efficiency and cost reduction. By eliminating the need for intermediaries, blockchain reduces transaction costs and increases efficiency. Transactions can be processed faster and more securely, without the need for third-party verification. For instance, Estonia's e-residency program uses blockchain to provide secure digital identities to its residents. This enables them to access various services, such as banking and healthcare, in a secure and efficient manner. Challenges and limitations of blockchain. Despite its many benefits, blockchain technology faces several challenges. Scalability issues. As the number of transactions increases, the blockchain network can become slower and less efficient. This is because every node in the network must process and validate each transaction. Solutions like the transition from proof of work POW to proof of stake POS and layer 2 solutions are being explored to address this issue. Energy consumption. The process of mining, especially in POW systems, consumes a significant amount of energy. This has raised concerns about the environmental sustainability of blockchain technology. Some blockchain networks are exploring more energy-efficient consensus mechanisms to mitigate this issue. Regulatory and legal challenges. The regulatory and legal landscape for blockchain is still evolving. Different countries have varying regulations regarding the use of blockchain and cryptocurrencies. This creates uncertainties for businesses and developers, impacting the widespread adoption of the technology. The future of blockchain technology. The future of blockchain technology looks promising with continuous advancements and innovations. Emerging trends, decentralized finance DeFi, non-fungible tokens NFTs, and smart contracts are some of the emerging trends in the blockchain space. DeFi is disrupting traditional financial systems by providing decentralized alternatives to banking, lending, and borrowing. NFTs are transforming the digital art and collectibles market by enabling unique digital ownership. Potential future applications. As blockchain technology matures, we can expect to see more industries adopting it for various applications. For example, the integration of blockchain with the Internet of Things can enhance the security and efficiency of IoT devices. Advancements in smart contracts can automate complex business processes, reducing the need for manual intervention. The role of blockchain in the digital economy. Blockchain is set to play a crucial role in the evolution of the digital economy. It can provide the infrastructure for secure and transparent digital transactions, fostering innovation and economic growth. Ethereum 2.0, with its focus on scalability and sustainability, is one of the key developments shaping the future of blockchain. Conclusion and next video teaser. In summary, blockchain technology is revolutionizing the way we handle data and transactions with its decentralized, transparent, and secure features. Its applications span various industries, offering significant benefits in terms of efficiency, security, and transparency. However, it also faces challenges related to scalability, energy consumption, and regulation. As the technology continues to evolve, it holds immense potential for transforming the digital economy. Thank you for watching. If you found this video helpful, please like, share, and subscribe to Financial Thinking for more insights into the world of digital finance. In our next video, we'll be exploring the topic of smart contracts and their impact on the financial industry. Stay tuned.